Okay, so we're going to try this again. This did not work the way I wanted it to, like a hot second ago. I tried to run this, I tried to run this slideshow and it kicked me out. It did some, it just kicked me out of my recording, which is not what I wanted it to do. We would like to keep that recording. So I'm not going to try that again, and hopefully I'll be able to get you where you want to go. But this is to help any students who miss the Desmos practice for the EOC. For you to be able to make that up, and I need to be ready to take my own notes. We can take them on this. Okay, great. So I want to take you through some of the stuff that Desmos can do for you. If you have access to the Desmos calculator during your EOC, it would be silly not to use it and not to know some of the things you can do with it. So the first thing for those of you that haven't is just get some experience graphing a function on Desmos. So go ahead, and if you don't have it open, like open Desmos in another window on your laptop or open it on your phone. What would be better, since you're going to be taking your EOC on a computer, is to maybe run this video on your phone and then have Desmos open on your computer. But you can switch that up, whatever's going to work for you. Have that open. So pause the video if you need to. And we just want to start by graphing a function. Make sure that you are able to use Desmos to generate the picture of a function, which is super useful even for questions like, what is the end behavior, or how many roots does something have, or what are the roots? We're going to talk about some of those later in this presentation. But when you're graphing a function, be sure to use y equals or f of x equals. Desmos will accept either or. Don't just type the expression. So if you were asked to graph like y equals 2x minus 3 on Desmos, you have to put the y equals. You can't just put 2x minus 3. Okay, so it should look something like this. And I'm going to hop on over, I hope, I'm going to hop on over to Desmos and do that one for you so you can see what it is, but I might have to close a bajillion things. So eventually measuring friction. Okay, we have like the late work form. Close that out. We have a circuit. We have a cam. We have, oh my word. Here we go. Finally, get down to enough. All right. So when you go to graph stuff, you want to make sure you have the y equals 2x minus 3. So you should see something like that. This will open up or hide your keypad, which you may or may not need. And then you want to notice that Desmos conveniently puts points, dots. Well, remember, there's points everywhere on the line. And if you click, and what I'm doing is I'm clicking and holding the mouse, I can click and drag any ordered pair. Okay, so like the point, what is that, 4, 5? I could get 4, 5 is on the line, even though Desmos didn't put a dot there. But Desmos kind of anticipates what are some of the important points that you might be interested in, and they put dots there for you so you don't have to click and drag. So this one has a root or 0 or x-intercept, just reviewing some vocabulary there, at 1.5. And remember, the y-coordinate of that is going to be 0. And then down here, your y-intercept, if you need it, the x-coordinate is 0 and the y-coordinate is -3, which you know because you have the -3 over there. So just like do that out. Just make sure that you're getting the same graph, that you're not doing something weird on that. Then apparently I have to make everything small. I don't know why I have a weird fusion thing out there. I don't know. Life is weird. All right, so some things that we want to make sure that we can use Desmos to do. So we're talking about systems of equations. We didn't really do a lot of systems in our EOC packet. So a system of equations is 2 or more equations that you solve at once. And so you're typically looking for both the x and the y value, but you want to make sure you're reading the directions. If you can answer the question by only finding the x or only finding the y, then make sure that you are not doing extra work. So a multiple choice test that gives you these options, you might be able to just do half the problem, and that's the kind of thing you want to leverage your multiple choice test for. One strategy for solving systems is by graphing and looking for the point or points of intersection. So however many points of intersection it has, that's how many solutions it has. So practice, suppose you had a system that looked like this. This is a quadratic, and then this is a linear one. And then what you need to do on a piece of paper is you're going to put your name on your paper, and you're going to write number 1. And then I want you to solve that system. Now, just so you guys can see, I will give an example of one. We're going to make that quadratic. So I'm going to pull this up and make that quadratic. Awesome. And then I will do, I don't know what we'll do, negative 3x minus 4. I'm making stuff up. Oh, that doesn't look great. Let me change that to minus 2. That looks a little bit better. I was just looking for something that had numbers that were like points that were a little bit easier. So again, you want to make sure that you don't let Desmos throw you off. Desmos doesn't know what you're trying to do. And so Desmos puts points wherever it thinks you might want them. But you've got to be the one to decide, like, is this a point that I want? So while this point is lovely right here, negative 2/3, 0, it's not a point we're interested in if we're trying to solve the system. You're looking for the points of intersection. So for this one of the solutions is negative 1.781 and 3.342. You always need the x and the y. And then the other solution is down here at 0.281 and negative 2.842. These 2 points, while maybe of interest, are not what we're looking for in this problem. So if you're asked to solve a system, you're looking for the points where they intersect. And I know when I gave a test on this that people just gave me the coordinates of every place that they saw a dot, and you can't do that. Like, Desmos is great and it's powerful, but it doesn't know what you're trying to do. Okay, so yeah, it doesn't know what you're trying to do, and so you need to and so you need to make sure that you are paying attention to the points there. All right, so what you're going to do is, I want this one, is you're going to solve this one. So pause the video. And if you're in class, we're going to stop class and I'm going to give you some time to do it and graph that. And next to the number 1 on your piece of paper, you're going to write the answers to that. So take a hot second and pause the video and write down your answers. Right. Next one. Using Desmos to solve equations you don't know how to solve otherwise. So there's all kinds of equations, and the awesome thing about knowing how graphs and equations are related is that you can figure out other ways to solve problems. So suppose you have a difficult equation that you do not know how to solve algebraically, and it could be an equation like that we haven't taught you how to solve, or it could be something that I have taught you how to solve, but you still don't know how to do it for whatever reason. And here's how you can use Desmos to solve that. So you can solve this using Desmos by graphing the left and the right as 2 separate equations and then finding where they are equal. Okay, and hopefully that makes sense to you. So you've got like the left side and you have the right side, and what you're looking for is where they are equal. Well, that is where they're going to intersect. So you're going to graph the left as its own equation and the right as its own equation, and then you're going to see where they intersect. So let's take a look at this one. So let me cross these guys out. And I'm going to take that left-hand side. Now, if you have to do the fractions, make sure that you get like the fraction, oops, sorry. When I go to put in my division symbol, it automatically turns it into a fraction. So make sure that you know how to do that. So that was the left side. And then the right side is 2x plus 3. Now, here's the beauty of this. Ooh, that is not what I wanted. Hang on, did I copy that right? 2x minus 3. There we go. Let's copy that right. Okay. There we go, better. And the beauty of knowing how to do this is that even though like that blue graph is not something that we've studied, it doesn't change any of the ideas. And all year long, I've been about the idea. Here's the idea. Here's the concept, because that concept is going to transfer over. The concepts don't change. So you could be looking at a graph that the shape is totally different from anything you've looked at. But if you know, like, graph the left side, graph the right side, and look for where they intersect. So here we go. We're looking for where there's an announcement.
This is an all call for Olivia Salisbury. If you're on campus,
right.
Please come to the main office. Olivia Salisbury, come to the main office.
Okay, so one of the solutions is 1.25, negative 0.5, and the other one is -1, -5. Now, go back to your original equation. We are looking for the x, okay? It is an x in here. So we actually don't want the y coordinate. We want the x coordinate only. So the solutions to this equation would be -1. So you'd say x equals -1 and x equals 1.25. And you would only want the x coordinates. So make like a little note of that, like you only want the x one. And I think a lot of times, you know, when you're looking at the answer choices, like that'll take care of it for you. Even if you have the y coordinate, you're not going to see them in the answer choices. So you'll have to go with the x's, but just remember it was x's in the original equation. So you can actually use that to solve any kind of an equation at all. This works 100% of the time, unless you have imaginary answers, which can happen, but is not really, really common, and it'll certainly get you all of your real answers. That is the answers that you can actually plot on a number line, and you're looking for where they intersect. So there's that example. So we'll do this one together, and so you need to write that answer next to problem 2. So I gave it to you. Like, go back. -1 and 1.25. Okay, so we did that one together. Pause the video if you need to. Write that down. Now you are going to try one on your own. So solve this equation using Desmos and write your answers next to problem 3 on your paper. So pause the video, graph the left, graph the right, and then get your answers off of the graph. You can do these problems other ways. You can do them by like factoring. You can do them with the quadratic formula, but like graphing is one of the ways that you can do them. So that's what we're reviewing today. Pause the video, find the answer to that one, and then resume after you've answered number 3. Okay, using Desmos to find the roots, also called the zeros or the x-intercepts. So I actually don't know what verbiage is used on the EOC, but it could be different from the SAT or the PERT. I know today that I'm recording this, we had a lot of PERT and SAT testing, but they're all synonymous, so roots, zeros, and x-intercepts. Sometimes you can use graphs to avoid factoring. Factoring is one of the kind of sticking points for a lot of students, and if you know what roots and zeros are, you can use the graphs to get around them. Again, it comes back down to the concept and that definition, knowing that
Kenneth Wiggins, if you're on campus, please come to the main office. Kenneth Wiggins, come to the main office.
Right. Hope that he goes to the main office. All right, so again, and this is why it's important to know your vocabulary, to know what these are, so that you're reading a problem and it says find the roots, and then you can think, oh, but I've got a graphing calculator, I can actually look at them. So if you were asked to find the roots, zeros of a function, try graphing it to see them instead of solving it algebraically. If you're confident algebraically, then you might use the graph to back up or give you some confidence. You can also use the graph to find end behavior if you don't remember the rules for end behavior. And so if you remember that like end behavior was a thing, but you're like, I don't remember the rules for the up, down, whatever, go ahead and graph it. Don't give up. So this was f of x. I'm going to use the y. And then to do any kind of exponent, you're going to use the a to the b, and that's going to bump me up to my exponent. And this is why I really wanted you guys to be doing this on a computer, just so you could get a little comfortable with the typing it in. Okay. And for this, I am looking for the roots. And so the roots are at -3, 0.5, and 4. And remember, the roots are the x-intercepts, so the y-coordinate is always going to be 0 because you're right on that x-axis. And Desmos is anticipating that that is a point you might be interested in. Remember that there are other points, so I can click all of those points are on that graph. But these are the ones that we're interested in. Bring those back. Now for the end behavior, you can kind of see how this one goes, like it's moving from left to right if you look up at the top there. And so on this one, the left is pointing down and the right is pointing up. And so you can use those graphs to help you answer questions on end behavior and the roots. So that's the example. And now you're going to do this one. Find the zeros and state the end behavior of this function and write your answers next to number 4. So there it is in all of its glory. So pause the video, graph that on Desmos, and state the roots and the end behavior. So you need to do both. And then unpause the video and move. Okay, so you can use Desmos. It does a whole lot of stuff. So now we're going to delve into, like, now that if you have this tool, what are some of the other things you can do with it? So remember the scary, I put scary in quotation marks. It's not really scary, but it looks a little intimidating if you've never seen it before. Sigma notation from the review packet. Desmos can evaluate this for you. So if you do not remember how to go about doing it, or we kind of lost you on that process a little bit, remember, but here's what you need to remember, like you, the doer of the math, because the computer is only going to do what you tell it to do. So you need to remember that sigma is a symbol for sum, S-U-M, meaning to add stuff up. So in that function box, if you type in the word S-U-M, okay, it's going to pop this up and you should just be able to fill in the blanks. So if you see this on your EOC, here's what you can do. In this little box up here, type the word S-U, and then watch as soon as I type the letter M, boom, and it pops up. And you can click around. So we're going to do n equals 2, but if you need to change the variable, and honestly, even if it gives you a variable I or J or something, you can just leave it as n, just use an n instead, it's fine. But you can click back and go in and change that. So we're going to do n equals 2, and then I use my mouse, I click right up here, so 5. And then right there, I'm going to type in 3n, and then we want to do squared. And there is your answer. And so Desmos will evaluate this for you if you don't remember. What you need to remember is that sigma means sum. So this is an adding problem, and that'll tip you off as to which command you need to write in Desmos. Okay. Next one. You try one. So I would like you to do this one. And you're going to write the answer next to number 5. Now, I went and changed the variable to a K there, and you can just type in, I'll like kind of hop on over to Desmos for a second. Like you can just do that and it'll change it. But notice that it's like not doing anything because my variables don't match. So you just got to make sure that you change, not that, yeah, change the other variable to match, but either one should work. So this is the one that you are going to be doing. You're doing K is equal to 3 to 8. So you're going to do 3, 4, 5, 6, 7, 8. So 4 to the 3rd plus 4 to the 4th plus 4 to the 5th plus 4 to the 6th plus 4 to the 7th plus 4 to the 8th. If you don't want to use Desmos, you can do it out by hand. But and then write that next to number 5 on your paper. Oops. All right, now using Desmos to find mean, median, standard deviation, and more. Okay, you guys can't see me, but my arms are like ta-da, like I'm ta-daing at my desk. So on the right-hand side of the keyboard, you will find a block labeled functions. It's right here, okay? Here, you're going to find trig functions, statistics, logarithms. There's like pretty much everything else. Tons and tons and tons of stuff. So I want you to go over there and find where it says mean, and then I want you to select that. Okay, so I'll hop on over here to Desmos. We're going to clear that out. We're going to open up this keyboard and click on functions. Notice if you need sine, cosine, tangent, cosecant, secant, or cotangent. If you need your inverse, and as a quick little review, remember the symbol for inverse is that superscript of -1. That is not sine to the -1. That is inverse sine. It is an inverse function. Here's all our statistics: mean, median, minimum, maximum, quartile, quantile, standard deviation, and then you'll see standard deviation with a P. One of them is a sample and the other one is population, okay? So one is sample, this is sample, this is population. I do not even know what the rest of this stuff is, okay? Mad core length. I know what the beginning part is. If I go down here. Join, sort, shuffle. These are like operations for logic. Visualizations, it'll do a histogram for you. It'll do a dot plot. It'll do a box plot. There's like all kinds of, whoops, I clicked on the help. I didn't mean to do that, but you can click on it. Normal distribution, we covered this like right at the end. Poisson, binomial distribution. Some of these I have covered. A lot of them I haven't covered, but there's your normal distribution. These are different tests you can do. Your calculus, you might need these ones, ln, log, and log base a. You probably don't need to worry about the d by dx or the f prime or that symbol, which is an integral, okay? But just heads up, like you've got some logarithm stuff. I might have put that at the end of this PowerPoint, I'm not sure. Hyperbolic trig functions, I remember doing those like once in my life. I don't even know what these do. Polygon, distance, and midpoint, those are formulas. Well, midpoint formula, distance formula, polygon is. Least common multiple, GCD. That's not greatest common factor. Ceiling and floor, I know what those are. Rounding, these are permutations and combinations. Here's a radical that's not a square root. Okay, so I guess if you wanted to do the fourth root of 81, oh look, the fourth root of 81 is 3. So tons and tons of stuff in there. And I finally made it all to the bottom. You won't see those. These are fun though, permutations, combinations. Least common multiple, whoa, we don't want to do that. I'm guessing, like now I just am having fun here. If I go to least common multiple and I do like 20, not 23, let's do 3, and I don't know, 3 and, no, I don't want to do 3. Let's do 6 and 9. Oh, look, the least common multiple is 18. So if you need to find the least common multiple, look at that. I'm just kind of having fun here. All right, so what did I tell you to do? I told you to go to statistics and find mean. Okay, there it is. So go find mean. Sorry for that digression. I get distracted having fun. So an example and on your own, it's just on the same slide. So we're going to find the mean for this set of data, 3, 4, 5, 5, 6, 7, 8. So let's go ahead and type that in. So we're going to put my cursor in here. 3, 4, 5, 5, 6, 7, 8. And the mean or average is 5.4, da, 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 da. So if you need to find the average, look at that. And if you click on that, it'll give it to you as a fraction. So if you want it as a decimal or as a fraction. So Desmos will change that for you. All right, so what I want you to do, Jim Halpert is watching you. There's a story behind why that's in there, but I'm not going to tell it. On your own, use Desmos to find both the median and the standard deviation of this list and write your answer next to number 6 on your paper. And I'm asking you to use that standard deviation P for population. So standard deviation for population. So you're going to use that data and then come on over here and you're going to look up in that table. You're going to look up median and type in the data, and then you're going to look up standard deviation population and enter the same data, and Desmos should give it to you. So median is 4, median is 4.5, and okay, and there's your standard deviation for the population. Just in case you're wondering, like if we did the standard deviation, the sample standard deviation, this one, and I do 3, 4, 5, 5. They're often very close. This is actually a really small data set, so they're further apart than they usually are. But for a big data set, they'd actually be close together. One of them, you just divide at the end, you divide by a number that's 1 off. So you're going to do that, but you're going to do it for this data. So pause the video at this point and go and find that, and you're going to write that next to number 6. Okay. Almost done. One topic that we did not cover was exponentials and logarithms. I am going to do this after the EOC. This is really important for those of you that are going on to pre-calculus. Like, I cannot send you to pre-calculus without addressing logs and exponentials. I'm pretty sure there's at least 1 or 2 questions on your EOC that are going to do this. And I'm not sure what concepts they cover exactly, but yeah, what concepts they cover, but I wanted to at least kind of address how you might solve those. So suppose you see the equations below, and then what we're going to do in class is discuss with a neighbor how you could use Desmos to solve them. Remember that, like, earlier in this presentation, I said how you can solve like anything that you're not sure how to solve by graphing the left and graphing the right as separate equations. So if you do have an equation like this, that log base 4, that subscript is a 4, you just need to know where to find it. So you would graph like the left and then graph the right. I'll make one up. We'll do like y equals, don't forget that y equals, and remember I said that log, it's under calculus for some reason. That's an ln. So log, and then I can put in base 3 of, we'll just say x squared, and then my other one might be y equals 4, okay? And you would be looking again for that x coordinate where they intersect. That comes out nice. -4 and 4. That one comes out really nice. But something like that, and you'll use that to solve. And again, the point of this is to just really empower you to be able to leverage that Desmos program, hoping that you have it, leverage that program for everything it'll do. For the E, I believe you can just type the letter E, and yeah. So if you wanted to do like 2E squared, well, that doesn't make sense. There's no variable in that, but you can just type the letter E, and that should be fine. So pause the video here, figure out how you can solve those, and write your answers. Make this one number 7 and this one number 8. All right. And last thing, to turn in, this is what you need to turn in. So make sure your name is on your paper and turn in all your answers to all 8 questions to show that you participated in this activity as intended. And if you are doing this via the video, well, I'm going to tell you to do something, but I want to go through this last minute EOC tips. Always read all the answer choices. Often the choices give a clue about how to find the answers. And you'll know that I did that so many times in that EOC review packet. I went and looked at the answers to see if there was an answer choice that didn't make any sense, or maybe a pattern in the answer choices, or realizing that I could do it with like half of it. There was that one that had if you could find the minimum of the parabola, you had the answer. You didn't have to look at most of the problem. You just had to find the minimum, which I'll just point out, okay, if you needed to find the minimum of a parabola, okay, you can just graph it and hover over it, and the minimum is going to be the y coordinate, okay? The minimum is the where it, x is where it happens, and the y coordinate is the actual lowest point. So yeah. Okay, so just make sure you're reading all those answer choices. Eliminate answer choices. It really helps. I know if you end up guessing anyway, it kind of feels like maybe it wasn't worth it to eliminate the answer choices because you still had a guess, but it really does help to make sure that you're not guessing certain things that you know are incorrect. Look for creative ways to solve problems. If you can't do it with an equation, try using the graph. Try to see what the solution is by graphing it, or individual points. So you know that for some of that inverse stuff that I'm bad at reflecting graphs, I would do the point and then flip the X and the Y, and I would just do it with the point. And then, so be creative. If you can't figure it out one way, remember that there's often another way that you can look at the problem, and you guys know more than I think sometimes you feel like you know. Skip harder problems and come back to them. So gauge your time, use your time wisely. If you begin to realize that a problem is going to make you anxious, star it, mark it for a review, and then come back to it. Don't leave anything blank. On most multiple choice tests, blank is equivalent to wrong, but don't do random guessing unless you have no other options, unless there is no way you can graph it or plot some points or look at a table. Like there's just nothing that you have to go on. I mean, even stuff with the sequences and series, like pick the number 1 and plug the number 1 in and see what happens when you plug the number 1 in. There's like stuff that you can do there. And then never change one guess for a different guess unless you know your first choice is wrong. Usually your first instinct is the better one. And I think it wants me to put a comma here, but I think they make me over comma stuff. Usually your first instinct is the better one. So if you have a hunch, like if you have this hunch that like a certain answer feels right, and then you start to have a different hunch, don't change your answer. Okay, do not change your answer unless you're sure that your first hunch was wrong. Don't change it because it feels wrong, because usually between the first hunch and the second hunch, your first hunch is the better bet. And I can't even count how many times students have changed a correct answer for an incorrect one, because they just started to second guess themselves and overthink it. So go with that first choice. Now, if you're sure the first choice is wrong, like if you are sure that you said that 2 plus 4 was 8, and you're like, but it's 6, so I know it's wrong, then go and change it. So if you are sure it is wrong, yes, go and change it, because now you've eliminated that one, but don't change it for a hunch. Now, if you are completing this lesson through video only, because you were not in class to do it, what I want you to do is hop onto Teams, and I want you to give me a GIF that shows how ready you are to take your EOC. So I would like you to entertain me by hunting down some GIFs. So I will demonstrate on my digital electronics board. So we're going to go to assignment submissions. You guys don't have an assignment submissions channel, so don't do that. I'll go to questions and discussions and start a new conversation. And then we're going to click on GIFs, and I'm going to type in test ready. Internal screaming. That sounds good. Okay. This was to demonstrate something for a video so they know. Internal screaming. So hopefully that's not how you feel about your EOC, but go for it, and hopefully we'll get some pretty entertaining stuff on our questions and discussions. So make sure it's school appropriate, okay? Like the system's pretty locked down, but don't try to get around it. And then maybe go and scroll up through the other ones and give your favorite ones a laugh or a happy face, smiley face, thumbs up, whatever you want. So that's what I want you to do when you're done with this, to document that you have done it. All right, so hopefully this lesson was beneficial and you feel better about how you can use Desmos, and we're going to cross our fingers and pray that we all have access to it. Okay, so that's that, and signing off.